Hello dear friends, welcome to my channel. Today's discussion is sequence series maxima and minima problem. So let's start to solve the problem. Number 1. Number of identical terms in the sequence 2, 5, 8, 11 up to 100 terms and 3, 5, 7, 9 up to 100 terms are. Problem very interesting. So common term is 5, 11, 17. Nth term of common sequence is Pn equals to 5 plus n minus 1 6 equals to 6n minus 1. Also 100 term of the first sequence equals to 2 into 2 plus 100 into 3 299. So friends, also the 100 term of the first sequence is 200 and 100th term of the second sequence is 3 plus 100 minus 1 2 is equal to 201. So common sequence is 6n minus 1 is obviously 6n minus 1 less than equals to 201. So n less than equals to 202. So n is equals to less than 33 1 by 3. So n equals to 33. Next, am greater than equals to gm. So a plus b plus c divided by 3 less than equals to abc whole to the power 1. And I can write this way: a plus b plus c less than equals to 3 into abc 1/3. Next, but given problem, this is the problem: ab square plus cc cube square b cube c to the power 4 a to the power a cube b to the power 4 c to the power 5 are in ab. Then the minimum value of a plus b plus c. I have to find out minimum value. But given is ab square c cube a square b cube c to the power 4 comma a cube b to the power 4 c to the power 5 are in AP. 1 ABC and a square b square c square are in AP. Since ABC, for that I apply the formula that 2ABC equal to a square b square c square plus 1. So that is ABC minus 1 whole square equals to 0. That implies ABC equals to 1. So a plus b plus c, a plus b plus c less than equals to to the power 1 by 3 greater than equals to 3. A plus B plus C equals to 3 of ABC is next problem. Next problem is 21 x square y square z square plus x plus 2y plus 4z whole square, then x, y, z are in. So 21 can be written 1 square plus 2 square plus square. It can be written 1 square plus 2 square plus 4 square into x square plus y square plus z square equals to x plus 2y plus 4z whole square. So that implies we can write this way: 1 square plus 2 square plus 4 square into x square plus y square plus z square minus x plus 2y plus 4z whole square equals to 0. Very simple. Can be written this way: 1 2 x y whole square plus 2 4 y z whole square plus 4 1 zx whole square equals to 0. So by Lagrange's identity, so y minus 2x whole square plus 2z minus 4 whole square plus 4x minus y whole square. Sorry, it is not y. It is 4x minus z. The possibility is y equal to 2x, 2z equals to 4y, and 4x equals to z. So y by x equal to 2, z by y equals to 2, z by x equal to 4. So y by x equals to z by y. So after that we get y squared is equal to xz. That is, therefore x, y, z are in GP. So are in GP. Next, the sum of the integer line between 1 and 100 both inclusive. Must remember, this is both inclusive and divisible by 3 or 5 or 7. So required sum, so S3 sum of the 3 is equal to sum of 3 is 5 is equal to sum of 5, and S7 equal to sum of required sum S3 plus S5 plus S7 minus S15 minus S35 minus S21. So as it is inclusive, that's why, so we get 33 divided by 2 plus 3 plus 99, 20 divided by 2, sorry, not 95, it is 100, and 14 divided by 2 equal to 7 plus 98, 100. Similarly, we get 15. So 15 divided by 100, 6. 6 by 2, 90, minus 35 divided by 100. So 35 divided by 100 equals to 2 by 2 divided by 35 plus 70. Minus 4 by 2, 21, 54. So friends, this is my total addition, and you should of some summation formula is that n by 2 a plus n minus, so this value will be 83 plus 1050 plus 735 plus minus 315 minus 105 minus 20 equals to 2838. Next problem is that one side of equilateral triangle is 24. Okay, the midpoints of its are joined to the form another triangle whose midpoints in turn joined to form another triangle, and this process will continue infinitely. The sum of the perimeters of all triangle is, so friends, 3 into 24 plus 6 plus 3 up to plus infinity is equal to 3. 1 minus half is equal to 3 into 48, 44. The total triangle is, perimeter of all triangle is 144 centimeter. Next, now see if x1, x2, x3, x2008 are in HP, and I equals to 1 to 2007 xi x plus 1 lambda x1 x 2008, then lambda must be equal to, so friends, given problem is x1, x2, x3 up to x 2008, so they are in HP, 1 by x1, 1 by x2, 1 by x3 up to 2008 are in AP. Then I can apply the formula 1 by x1 equals 1 by x3 minus 1 by 2 dot 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 equals to 1 by x 2008 to x3 equals to x 2018 2007 x 2007 minus 2008 equals to D. So by the laws of proportional, we have x1 minus x2 plus x2 minus x3 plus up to 2007 2008. x1 x plus x 2008 into x 2007. So this value equals to D. This is called laws of proportional. By law of proportional equals to x1 minus x 2008 divided by x1 x2 x3 2008 into x 2007 equals to D. So x1 x2 plus x2 x3 plus so x1 divided by 2008. So summation I equals to 1 to 2007 x I plus 1 x1 into x 2008 divided by D. This can be written as 2007 x1 x 2008. How friends? Because 1008 equals to 1 by x1 minus 1 into D. Therefore, we can write this way minus x 2008 divided by x1 2008 equals 2007 D. So divided this and we get value equals to this value. We can write x1 minus x 2008. Number three. Next problem is r equals to 1 to tr n into this problem. And after that we have to find tn equals to, it can be written r equals to 1 to n. Tr equals to r equals to 1 to n minus 1 tr. So in this way we get n plus 1 into n plus 2 into n plus 3 divided by 8. So friends, this answer is 2000. So friends, I just put in here all the value. So this value is n minus 1 n n plus 3 n plus 4 divided by 3. So it's not 3, this divided by 8. So after calculation we get this value is n into n plus 1 into n plus 2. So summation r equals to 1 to n 0 40016 divided by, you know, this answer is 2007. So this is another problem and this is this problem. So it can be written r equals to 1 to n equals to 416 divided by r into r plus 1 into r plus 2 into 2 equals to, we can write 4016 summation r plus 2 minus r divided by r1 into r plus 2. This equals to 4016 summation r equals to 1 to n divided by r plus 2. 4016 can be written r plus 1. So it can be written this way: r equals to 1 to n equals to 1 by r into r plus 1 minus 1 by r plus 1 into r plus 2. Now, after breaking this summation, I apply, this is the telescopic series, kind of series. You have to solve that. After that, we get 4016 half minus 2 divided by n into n plus 2. So limit n tends to infinity, 4016 minus 2 divided by n plus 1, n plus 2 can be written as 20 8. So my answer is 2008. Next problem is very simple. R equals to 1 to 19 to the power 4 plus r square plus 1, then the value of 819 8191 s. So s can be written this way: half into summation r equals to 190 r over 4 r square plus 1 summation 1 plus r squared 1 minus r plus r squared divided by 1 plus r squared into 1 minus r plus r squared equals to minus half minus 1 by 1 minus r plus r squared. It can be written this, and after that I can write the, again this is a telescopic series, coping series. It can be one cut, and it can be this value will come 1 divided by It is not infinity, it is 90. So as it is 90, so it is 90 plus 90 squared minus 1 by 1. This value will come by minus 8191, and that implies 8191 is equals to 8191,902 equals to 4095. 4095. In here we see that 128 is into 8 into n. So we see that n equals to 16. So S can be written as R equals to 1 to 16, 8R divided by 4 r to the power 4 plus 1, because 2 to the power 18, 2 to the power 18 can be written 2 to the power 4 into 2 to the power 14. So it can be written this way, that 4 into 16 to the power 4 means 2 to the power 18. So I can write this equation as this way. So this is a general term. So I can write this equation as this way: r equals to 1 to 16, 8r divided by 2r squared minus 2r plus 1. So friends, it can be written 2r squared into 2r squared plus 2r can be written multiply equals to summation into 2 into can be written 1 by squared minus 2r plus 1 minus 1 by 2r squared plus 2r plus 1. So it can be written 2 into 1 by 1 minus 1 by 5 plus 1 by 5 plus minus 1 by plus 1 by 13 equals to plus dot 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 minus 1 by 545. So it can be written this way: 2 into 1 minus 1 by 505, and after that it can be written 1088 divided by 545. So this is my answer. Now we will solve next problem. Now we will solve the next problem. Height 6 square by 7 square, 9 divided by 7 square by 11 square, 13 divided by 11 square by 15 square plus dot 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 up to infinity. In its term, infinite terms. So I have to find out Tn. N equals to 5 plus n minus 1 into d plus n minus 1 d is, this is the whole square, 7 plus n minus 1 whole square. After that, we can write this way: 1 by 8, 1 by 4n minus 1 whole square, 1 by 4n minus 3 whole square. Because this portion can be written after simplifying 5 into 4. D is in here 4. So it can be written 4n divided by 4n minus 1 whole square is plus 1 into 4n plus 3 whole square, it is plus 3. So Sn equals to 2 plus t3 up to n. So Sn equals 1 by 8 divided by 3 square plus 1 by 7 square minus 1 by 7 square plus 1 by 11 square minus 1 by 11 square up to root. And last one will be 1 by 4n plus 3 whole square. All term will be cut because it is telescopic series. So to 1 by 9 minus 1 by 4n plus 3 whole square, and limit n tends to infinity, Sn is equal to 1 by 72. So we get the value is 1 by 72. Now friends, the problem is next, number 11. So obviously we know k equals to 0 to infinity minus 1 to the power n x to the power 1 to the power k x to the power k equals to 1 plus x. So summation a equals to, in here, 1 divided by 1 plus tan square x, and b equals to 1 divided by, so summation tan square x cot square x whole to the power k can be written as 1 divided by 1 minus tan square x into cot square y. Sorry, it is cot square y. So after that we can write this way, that 1 by 1 minus 1 by a minus 1 into 1 by b minus 1. Now friends, you see that 1 by a equal to 1 plus tan square x. So tan square x is equal to 1 by a minus 1 Similarly, minus that we get a value AB divided by A plus B minus 1. Just simple calculation. And we get the value is 1 divided by 1 by A, 1 by B minus 1 by AB. Next problem is AM greater than equals to GM. So root over x square plus x plus tan square alpha divided by over x square plus x divided by 2 greater than equals to x square plus x tan square alpha divided by root over x square into x. So that we get root over x square plus x square plus x and then equals to 2. Answer is 2 tan alpha. Now we are going to solve this problem. Test of convergence. Which of the following is true? This is the minus 1 to the power n divided by n is equal to alternating monotone sequence, monotone decreasing sequence, monotone decreasing sequence. It is the follow by Lipschitz rule. It is convergent. True. This option is not true because this portion is divergence. Because 1 by n to the power p, this series is p series. P greater than 1, then series is convergent, then series is divergent. That's why this series is divergent. Equals to, friends, we see that this is converges, this is does not converges, this is wrong, this is wrong, this is wrong because this is divergence, this is convergence. So next problem is on one series, very interesting, that is summation n equals to 1 to infinity summation m equals to 1 to infinity 1 by m plus n whole square. So friends, it can be written this way: summation n equals to 1 to whole infinity 1 by n plus 1 n plus 2 whole square up to infinity. After that, it can be written this way, that n equals to 1 to infinity n divided by n plus 1 whole square. How? Because friends, if you summation n equals to 1 to infinity 1 by n plus 1 whole square plus 1 by n plus 2 whole square up to infinity can be written this way: 1 by 2 square plus 1 by 3 square up to infinity plus 1 by 3 square plus 1 by 4 square up to infinity and plus 1 by 4 square plus 1 by 5 whole square up to infinity. So we can up to infinity. So we can write up to infinity. So we can write this equation as summation n 1 to infinity n divided by n plus 1 whole square. So friends, I hope that I can clear that how I can write this way. And now we can take en equals to summation n equals to 1 to infinity n divided by n plus 1 whole square. En we can take this way. We can write this is an equals to, and bn equals to 1 by n. Now limit n tends to infinity, an by bn equals to limit n tends to infinity n square divided by n plus 1 whole square equals to 1. So that as an bn is divergent, so an is divergent. That's why option 4 is correct, is incorrect. So friends, we will go to solve the next problem. Saddle point. X cube plus 2xy plus y cube has a saddle point at 0, 0. So at first I write f equals to x cube plus 2xy plus y cube and del f by del x is equal to 3x square plus 2y and del f by del y is equal to 2x plus 3y square, and after that I get del square f by del x square is equal to 6x and del square f divided square is equal to 2. After that del f by del x del square f del f del y equals to 2. Okay, this value is 2. So you can write it is r, it is t, it is r, and this is s. So rt, the formula is rt minus s square. Rt is 36 yx minus 4. Now we will check the option which is satisfy that if it should be saddle point. When the problem is saddle, it should be 0. It should be 0. So first option, when we put 0 comma 0, then it is less than 0. So first option is correct. RT minus s square less than 0, then it is saddle point. After that, if we put number B, putting this option number B, then you see that 36 means it is not, it is greater than 0, and others all option you get. So all option is not possible, because if you check this better, that all option does not satisfy this condition, only first option satisfies. So saddle point at 36 yx minus 4. Note, maxima and minima of functions of two independent variables. Let fxy be any function of two independent variables x and y, supposed to be continuous for all values of these variables in the neighborhood of their values a and b respectively. Then if ab is said to be a maximum or minimum value of fxy according to if a plus h and ab plus k is less greater than if ab for all sufficiently small independent values of h and k, positive or negative, provided both of them are not equal to 0. So necessary condition, the necessary condition is that condition that fxy should be maximum or minimum at x equals to a at x equals to b is that del f by del x x equals to a, y equals to a, del f by del y equals to 0. And sufficient condition is that r equals to del square f divided by del x square, x equals to, and h is equal to del square f divided by del x into del y. And we get t equals to del square f del y square. Then fxy will have maximum or minimum value x equals to a if rt greater than 0. So friends, rt minus s square is greater than 0, then maximum and minimum value exist. Maximum and minimum value exist, and further, if xy is maximum value r less than 0, then it is maximum. R less than 0, then it is maximum, and minimum is r greater than 0. R greater than 0 is maximum, and r less than 0 is minimum value is r less than 0. So if fxy will have neither maximum or nor or minimum, x equals to a and y equals to b, if rt greater than s square, x equals to a and y equals to b is saddle point. Hence, whatever you see, we see that rt, in this case, you see rt minus s square greater than 0. This means rt is greater than s square. This is the saddle point. This point is saddle point. And rt equals to s square. This case is doubtful case. Further advanced Investigation needed to determine whether fxy is equals to a, y equals to b. So I hope I cleared this total concept of maxima minima. Now I will solve another problem based on maxima and minima. Optimal values. Friends, next problem. A function is given as fxy 4x square plus 6y square minus 8x minus 4y plus 8. Find the optimal value of f(x), y. So f is equal to, I can write 4x square plus 6y square minus 8x minus 4y plus 8, and del f by del x is equal to 8x minus 8, and del f by del y is equal to 12y minus 4. And according to the condition, we know that 8x minus 8 equals to 0, so x equal to 1, and this portion is 0, so y is equal to 1 by 3. This is y value. Okay, after that, del square f divided by del x square equals to 8, and del square f divided by del y square equals to 12, and del f by del y into del x equals to 0. So this is it can be written s, it can be written t, it can be written r. We see that r is greater than 0, so it is the value should be minimum possibility. Now we check that it is maxima or minima. So rt minus s square equals to 8 into 12. How 8 into 12? 96. 96 minus 0, so it is greater than 0. So maxima or minima exist. Maxima and minima exist. So we see that r is greater than 0. We see r is greater than 0, so minimum value exists. Minimum value exists. So my optimal fxy is equal to, what is my value? X is equal to 4, y is equal to plus 6 by 9 minus 4 minus 4 by 3 plus 8 equals to 10 by 3, which is minimum. Which is minimum. Next, find the distance between the origin and the point nearest to its surface. Z square is equal to 1 plus, so z square is equal to 1 plus xy, and distance from origin is equal to and point P equals to x comma y comma z. So it is x square plus y square plus z square. So it can be written root over x square plus y square is equal to 1 plus xy. U is equal to, so we can write u is equal to x square plus y square plus 1 plus xy. So we have to find out the maxima and minimum value. So how can we find out the value? Do we del u by del x is equal to 2x plus y, del u by del y is equal to y plus x, and del u by del square u divided by del x square is equal to 2, and del square u divided by del y square is equal to 2, and del square u divided by del x into del y equals to 1. So this is r, this is e, and this is a s. So rt minus s square equals to 4 minus 1 equals to 3 greater than 0. So maximum and minimum value exist. Maximum or minimum rt minus s square is equal to 3 greater than 3. This is the del square u divided by del x square, and del square u del o square is equal to, okay, r greater than 0. So it is minimum value exists. So minimum value exists. Now we will write that 2x. So x equals to 0, y equals to 0 after solving this, and after that we get, and z equals to root over 1 plus z square is equal to 1 plus xy, and it is 1. So z equals to plus minus 1. So the point nearest to the origin on surface is 0, 0, 1, and distance is, and the distance equals to root over 1 square plus 0 plus 0 equals to 1. So we get the value. Now friends, next problem is x plus x square cos pi by x DIFR problem, and x does not equals to 0 where, and 0 where x equals to 0. F dash 0 exists and equals to 1 f is not increasing in any NBD of 0. F dash x does not exist and f is increasingly on R. This option we see. Now we will get the differentiable or not. We will check f dash a is equal to limit h tends to 0 f a plus h minus f a divided by h. So f dash 0 is equal to limit h tends to 0 f 0 plus h minus f 0 divided by h equals to limit h tends to 0 divided by h plus h square cos pi by h. Must remember f0 equal to 0 according to the question. So it is 0 divided by h. It can be written this way, that 1 plus limit h tends to 0 h into cos pi by h equals to 1 plus 0 equals to 1. So friends, what we see that this option is correct. F dash 0 exists and equal to 1. F is not increasing at any NBD of 0. So f dash x does not exist. This option is wrong. And f is increasingly on R. We will check. So friends, this is the 0. I will draw the graph this way. This way. This graph is this way. So increasing in any NBD of 0, this is not true. And f is increasingly on R, this is also not true, because this is this way, the graph is on this way. After that friends, let f such that R tends to R be continuous one function, then which of the following is true? So friends, next problem is, let f such that R tends to R be continuous and one function, then which of the following is true? F is either strictly increasing or strictly decreasing. F is onto and there exists x belongs to R such that f is equal to 1, and f is unbounded. So friends, this problem is very nice problem. Choose some example. Let fx is equal to e to the power x and f is and 1 to 1 to 1, but fx does not equals to for all x belongs to capital R, so that f is not onto. So option 2 is wrong. And next example, fx is equal to 1 plus e to the power x. F is continuous and 1 fx does not equals to 1. So option 3 is not correct. And next example is fx equals to 1 by r x continuous and 1 function e to the power x, range is infinity 0 to infinity. So 1 less than 1 by 1 plus e to the power x is infinity, so it is bounded. So f is unbounded. This is also wrong. Only this option, f is strictly increasing and strictly decreasing, this is correct, because f dash x is 1 that means f dash x greater than 0, then it is increasing, or otherwise f dash x less than 0, then it is decreasing. So we have understood that f is either strictly increasing or strictly decreasing. This is possible. Next problem is uniform continuous problem. Let Gnx is equal to nx divided by 1 plus n square x square to 0 to infinity. Which of the following is true? Gn tends to 0 pointwise, but Gn tends to 0 uniform, and Gn tends to x, and Gnx is equal to x tends to x divided by 1 plus x square. So friends, we need to learn what is pointwise convergence. Pointwise convergence: let D be a subset of R and let Fn be a sequence of function defined on D. We say that convergence pointwise on D if limit n tends to infinity is equal to Fn exists for each point x in D, and if Fn is pointwise convergent, then the function defined by n tends to infinity Fnx equals to Fx for every x in D is called pointwise limit of the sequence Fn. Uniform convergence: limit n tends to infinity Fnx is equal to Fx. Uniformly convergent means limit n tends to Fnx minus Fx is x belongs to D equals to 0. So how can we get uniform convergence? There is a MN test. Find limit n tends to infinity Fnx equals to Fx. After that, limit Fnx minus Fx is equal to Hx, and calculate maximum of Hx and solve h dash x is equal to 0. Suppose x0 is solutions point of 1 if h double dash x is equal to 0 greater than 0. So friends, limit n tends to infinity supremum fnx minus fx such that x tends to 0 equals to 0, then it is uniformly convergent. So friends, I just discuss the procedure. How can I find out the function is uniformly convergent or not? So friends, this is the meaning of that. Limit n tends to infinity. Our supremum value is hx. So I write supremum hx equals to 0. That is, then we can say the function is uniformly convergent. Now we see that n to the power a x to the power b 1 plus n to the power c x to the power d. So ad minus bc less than 0. Then it is UC. So this is the shortcut technique. This is important result. So friends, I use this result for finding that. Otherwise you can solve it easily, the procedure that how can you gnx limit n tends to, at first you find out limit n tends to infinity gnx. In this process, what is the value, that is the gx, and after that you have to hx you have to find out, and gx is equal to gnx is equal to 0, and hx is equal to supremum gnx minus gx, and after that you will use that h dash x. After that you have to find out h dash x, and h dash x value equals to 0. Then you get value x1 x2, and h double dash x, check this value is less than 0, then it is maximum. Just I am just telling because as it is the very learning point of the BSc MSc all the course, so that's why I am telling how to find out this h double dash x less than 0. Okay, clear? H double dash x is equal to less than 0 if then limit n tends to infinity hx is equal to 0, then you can say it is UC, otherwise not. But this technique is very large, so that I just use this shortcut result because for competitive examination AD minus BC. So my problem is that, what is my problem? My problem is n square x divided by 1 plus n x square. I hope this is my function. My function, I just write my function. Where is my function? My function is this nx n square x square. Sorry, nx n square and x square. So in here comparing this, so a equals to 1, b equals to 1, and c equals to 2, and d equals to 2. So we will get that ad equals to 2 and bc is equal to 2. So 2 minus 2 equals to 0 and uc. So my option 1 is correct. It is point wise but not uniform, and others everything is not correct, because as it is coming CSIR 2019 part C, part B, so only one option is correct, so that this option is correct. Now next we will discuss, next problem is based on directional derivatives. How to find out directional derivatives? So my function is fx comma y is equal to x cube minus y square divided by x square plus minus x square minus y square, and direction of derivative is equal to d u bar f x comma y equals to limit x tends to 0 f x plus hu ah plus y plus bh minus y divided by h. So that friends, I can write this way: d u bar f x comma here x comma y is equal to 0, so 0 comma 0 is equal to limit, this is the x tends to not h tends to 0, so it is h tends to 0 f 0 plus 4 by 5 h and 0 plus 3 by 5 h minus f 0 comma 0 divided by h. So that after that I can write this problem this way, that limit h tends to 0 1 by h equals to 4 by 5 h whole cube minus plus, this is because the sequence is x cube plus, problem is x cube plus y cube, so it is x cube plus 4 by h by 4 by 5 h cube divided by 3 by 5 h whole cube divided by 4 h whole square plus minus, it is not plus, it is minus 3 by 5 h whole square equals to 64, 4 plus 27, 7 divided by 7, this is the 125 divided by 7 by 25 equals to 13 by. Next problem. Decide which of the following functions are uniformly continuous on 0, 1. So friends, uniform continuous problem, that a function fx is uc on a comma b interval when limit x tends to a fx a plus is equal to finite, and limit x tends to b minus fx is equal to finite. So friends, we get this value, so that then it is easy. UC, uniform convergence. So fx is equal to e to the power x, then limit x tends to 0, fx is equal to limit x tends to 0, e to the power x 1, e to the power x is equal to e. So friends, we see that this portion is uniformly continuous, and after that if we check number b, that limit x tends to 0, x equals to 0, and limit x tends to 1, x is equal to 1, get finite value. So it is also UC, but this portion is not UC because limit x tends to 0, 0 tan pi x by 2 equal to limit x tends to 1 tan pi by to infinity. So that it is not UC, but this portion is UC because it is sine 1 and sine 0. Limit x tends to 0, sine 0, sine equal to 0, and limit x tends to 1, sine a. That this concept. Next problem is based on uniform convergence. Nice problem. This is the, let f such that r tends to 0 comma infinity be a continuous function such that gx is equal to fx whole square is uniform continuous. So this problem, we see that gx is equal to fx whole square, and this is uniform convergence. Uniform convergence formula: a function f such that x tends to y is said to be uniform convergence, is said to be uniform if for all epsilon greater than 0 there exists del greater than 0, and such that mod of x minus y less than epsilon, mod of less than del, and fxy and mod of fx minus mod of y less than epsilon. Now gx fx whole square, so fx is equal to root over gx, and fx is equal to, so fx is equal to root over gx is equal to h composed gx, we can write, and hx is equal to root over gx such that r tends to 0 comma infinity, and hx 0 comma hx does not equal 0 comma infinity tends to 0 to infinity. Gx is UC, so hx is, so f is UC, this is correct, and f is bounded, this is correct, and others is not correct, because if it is UC, then you see that root over x minus y less than del, so that implies hx minus hy less than del, less than epsilon. So number question number 22, which of the following function is periodic? Which of the following functions is periodic? Signum e to the power x, b sin x plus mod sin x, c mean of sin x comma mod sin x, and x plus half x minus half plus 2 minus x, blocks integer, test integer. So friends, now we have to learn what is periodic function. A function returning to the same value at regular intervals if x plus np equal to fx and if ax equal to p divided by mod a. So first is option A. For option A, signum x sgn x, signum function x is equal to 1 0 minus 1, x greater than 0, x equals to 0, and x less than 0. Therefore signum means sine e to the power, but a sine not sgn, sine e to the power minus x equals to 1. So sine sgn, therefore sgn is constant function. Hence it is periodic. Now for option B. Option B, therefore periodic of sin x is 2 pi, and period of mod of sin x is pi. So period of x plus mod of sin x is equal to 2 pi. Now for option C, let fx is equal to mean of sin x comma mod x, so equals to sin x. Sin x is less than mod x, so sin x is periodic with period pi. Now for option D, fx is equal to greatest integer x plus half plus greatest integer x minus half minus plus 2 into greatest integer minus x. So it can be written this way: x plus half minus x plus half. This is the fractional integer plus x minus half minus x minus x fractional integer. This is the total. So we get, after calculation, we get this value is minus x plus half minus x minus half minus 2x. So this is the option D. So it is fx is periodic. Now friends, we will solve another problem. Question number 24. Let a is equal to t sine 1 by t and t belongs to 0 to 0, 2 by pi. Which of the following statements are true? Supremum of a, infimum of a, supremum of a is equal to 1, infimum of a is equal to 1. So my a equals to t sine 1 by t and sine 3 pi divided by 2 equals to minus 1. 1 by t equals to 3 pi by 2. So value of a at 2 by 3 pi and 2 by 7 pi, that is minus 2 by 3 pi minus 2 by 7 pi minus 2 by n pi. So infimum of a less than minus 2 divided by 3 pi minus 1 by n pi. So This option is correct. And sine pi by 2 equals to 1. So 1 by t equals to pi by 2. So t equals to 2 by pi. So supremum of A is equal to 2 by pi. So supremum of pi plus 1 by n pi. So this option is correct and this option is not correct. This option is not correct. Now let fx is equal to 5 by 12 whole to the power x plus 12 by 13 whole to the power x minus 1 for all x belongs to R, then value of the following statements are true. The equation px equals to 0 has exactly one solution in R. Px is strictly increasing for all x belongs to R. The equation px equal to 0 has exactly two solutions in R. Px is strictly decreasing for all x belongs to R. So fx is equal to 5 by 12 to the power x plus 12 by 13 whole to the power x minus 1. So f dash x f dash x is equal to 5 by 12 whole to the power x log e 5 by 12 plus 12 by 13 to the power x log e divided by 12 by 13. It is greater than equals to 0. It is less than equals to 0. It is greater than 0. It is less than 0. It is less than 0. So it is strictly decreasing. Fx equals to 0. 5 by 12 whole to the power x plus 12 by 13 whole to the power x equals to 1. So fx equals to dx. So this portion is fx and this portion is gx. So the graph will cut only exactly one point. So first option is correct. The equation fx or px has exactly one solution in R. Fx is strictly increasing function. This is wrong. The equation fx equal to 0 has exactly two solutions. This is wrong. And fx is strictly decreasing function. Now an is equal to n equals to 1 is positive real integer. An is convergent. Which of the following series are convergent? Now an obviously greater than an divided by 1 plus an. So by comparison test, this is convergent. Now another problem is an to the power 1 by 4. Now for number B, okay, number C I will solve that n into an sine 1 by n equals to n into an 1 by n. So sine 1 by n equivalent to 1 by n. So it is cut. So it is convergent. So this portion is convergent. Convergent. Number B. Holder inequality. If an and bn are sequence of real numbers, where the following is converges, means CGT, or a given P and Q belongs to capital R, such that 1 by P plus 1 by Q equals to 1. So, and mod of summation A n P less than infinite and summation mod of B n whole to the power Q less than infinite. Then mod of A n B n whole to the power summation A n whole to the power P 1 by P and summation mod of Bn whole to the power Q 1 by Q. This is the Holder's theorem, friends. Now summation n equals to 1 to infinity A n 1 by 4 n to the power minus 4 by 5. This is A n and this is B n. Here P equals to 4 and Q equals to 4 by 3. Then summation A n whole to the power 1 by 4 whole to the power P equals to A n equals to CDT. Similarly, summation n to the power minus 4 by 5 whole to the power P whole to the power Q means summation n to the power minus 4 by 5 Q equals to 4 by 3 equals to summation n to the power 16 by 15. 16 by 15. This is minus equals to summation 1 by n to the power 16 divided by 15 convergent. Is convergent. So friends, summation A n whole to the power 1 by 4 n to the power minus 4 by 5 5 less than equals to summation a n whole to the power 1 by 4 into 1 by 4 whole to the power 4 power 1 by 4 into summation n to the power minus 4 by 5 into 4 by to the power 4 by 3 into 3 by 4. So this way we can see that this is, and hence this is convergence CGT. Next question is question number 20. Let S be the set of alpha comma beta belongs to R square such that x to the power alpha y to the power beta over x square plus y square tends to 0 as x comma y tends to 0. Then S is contained in alpha comma beta, alpha greater than 0, beta greater than 0, alpha comma beta, alpha plus beta less greater than 1, alpha comma beta, alpha greater than 1, beta greater than 1, and alpha plus beta greater than 1. So fxy equals to x to the power alpha y to the power beta divided by x square plus y square. And y equal to mx and x tends to 0. So f is equal to limit x tends to 0 x to the power alpha mx to the power beta divided by root over x square plus mx whole square equals to limit x tends to 0 x to the power alpha plus beta m to the power beta 1 plus m square over which is tends to 0. It is tends to 0 if alpha plus beta greater than, because degree of of numerator greater than degree of denominator. So alpha equals to 1 and beta equals to 1. So fx comma mx equals to limit x tends to 0 x square m to the power beta divided by x root over 1 plus m square tends to 0. So alpha greater than 0 and beta greater than 0. So my first option, this option is correct. The second option is correct. First option is wrong. Third option is wrong. Now we check fourth option. Now alpha equal to 1 by 4, beta equals to 1 by 4. So alpha plus beta plus 1 by 4. If alpha plus beta greater than 1 and alpha greater than 1 and beta greater than 1, then alpha plus 4 beta now let f such that r tends to r be a non-decreasing function. Which of the following can be the set of discontinuous of f? So friends, non-decreasing function equals to an increasing function as countable discontinuous. So friends, number z, this is number n, and number q is discontinuous of f, and number 4 is no option discontinuous, not discontinuous. Next friends, next is number 29. Fx is equal to x by sine 1 by x for x belongs to 0, 1 and 0 for x equals to 0, and gx is equal to x fx for 0 less than equals to x less than equals to 1. Then which of the following are true? F is bounded variations, f is not of bounded variations, g is of bounded variation, and g is not of bounded variation. Fx is equal to x to the power m sine 1 by x to the power n, where x belongs to 0, 1 and equals to 0 when x equals to 0. So if m greater than n, limit exists. Then it is bounded variation. If m less than equals to n, then limit does not exist. Limit does not exist and not bounded variation and not bounded variation. So in here n equals to m, so not but does not exist limit, so it is not bounded variations. So f is of bounded variation, this portion is wrong. Number 2, if is not bounded variation, this is correct. G is of bounded variation, this is correct. And G is not bounded variation, this is wrong, because fx gx is equal to fx into x, so it is can be written x square sine 1 by x. So in here m greater than n, so limit exists, that's why g is bounded variation. Next problem is based on comparison test. So according to the comparison test, if an greater than bn, an is CGT, then bn is CGT. If bn is DGT, then an is DGT. Always remember, bigger is convergent, then smaller is convergent. If smaller is divergent, so bigger is also divergent. So we see that xn in here yn xn greater than yn in this case, as yn is equal to xn divided by 1 plus xn. So by the comparison test, if xn is convergent, if yn is convergent, so number 1 is correct. Number 2, if yn is convergent, if xn is bounded. If yn is convergent, if xn is bounded. Yeah, obviously xn is bounded. So xn is bounded means it is good. this problem will solve. Now next question number 31. The radius of convergence of n equals to 0 to infinity 4 to the power 1 minus 1 to the power n into z to the power 2n is. Now friends, we have to find out the radius of convergence of the power series. Let un equals to minus 1 to the power n. Un is equal to minus 1 to the power n equals to 1 when n is even. N equals to even, and minus 1 when n equals to odd. And un equals to 4 to the power n z to the power n when n equals to even and equals to 4 to the power minus n z to the power 2n when n equals to odd. So now n is equal to 2n. Here 2n is equal to m. So n equals to m by 2. So un equals to, sorry, not un, an equals to 4 to the power m by 2 into 4 to the power minus m by 2. M is even, m is even, and m equals to odd. By Cauchy test, 1 by capital R is equal to limit n tends to infinity 4 to the power m by 2 into 1 by m equals to 4 to the power half, that is 2. So capital R is equal to 1 by 2. Similarly, limit n tends to infinity 4 to the power minus m by 2 to the power 1 by m equals to half. So 1 by r. So r equals to r1 equals to 2, and this is r2. So r2 is equal to 1 by 2. Now capital 1 by r is equal to supremum of 1 by r1 or 1 by r2. So we get 2 comma 1 by 2 and supremum value, so it equals to 2. So r equals to 1 by 2. So radius of gyration, radius of convergence. Next friends, if z is equal to mod z whole square plus iz bar plus 1. So if z is differentiable, then del f by del z bar equals to 0. Now mod of z whole square is equal to z into z bar. So
fz equals to z bar plus I z bar plus 1 and del f by del z bar equals to z plus I equals to 0. So z equals to minus I. So at the answer is minus I. Now the function fxy is equal to this has local minima at minima and maxima. So friends, my f x comma y x cube plus 3x y square minus 4 y square minus 15x. So del f by del x is equal to 3x square plus 3y square minus 15 and del f by del y is equal to 6xy minus 8y. So friends, according to it is 0, this is equals to 0. So del square f divided by del x square is equal to 6x minus 15 and del square f divided by del y square is equal to 6x minus 8. Now del square f divided by del x into del y equals to 6y. Okay, equals to 6y. So friends, this is my r, this is my t value, and this is equals to s. So rt minus s square. So I have to check that which value satisfies these equations. Now first value, if I will put this first value, so it is satisfaction I this condition, and also this value does not satisfy this condition, because if I put this, then it is 6 root 5 and after that it is 0. So how can it will become 0? First condition satisfy, and second condition also same, it satisfies second conditions, but third condition is not satisfied, and this portion satisfy does not satisfy this portion. 1 minute, del f by del y equal to 6y minus 8y. Okay, root over 5 comma 1, this portion and this portion both satisfy this. So my root over 5 comma 0 and root over 5 minus root over 5 comma 0 is my extremum point. Now after that, if I put this value 6 root 5, so in both case r is less than 0 and rt minus s square, rt equal to, oh, I did mistake in here 6x only, square divided by del y. Sorry, I have written wrong in here in case it is cube. This is cube and this is 8y square. Okay, now it is coming not 8, it is coming 12y square. 6x minus 24y minus del square divided by y square equal to 6x minus 24y. Now r is equal to root 5 comma 0. If I put, then its value is t minus s square greater than 0. Satisfy. And 6x, this condition satisfy maxima. So this option is obviously correct, and this portion is wrong, and this portion is also wrong, and this portion is wrong. So my option D is correct. Next, we will go to solve.
The following series is divergent. So is the 1 by n sine square 1 by n, number B 1 by n log n, C 1 by n square sine 1 by n, number D n equals to 1 to infinity 1 by n tan 1 by n. So friends, first formula is 1 by n sine square 1 by n tends to 1 by n sine square 1 by n equals to 1 by n into 1 by 1 by n square n cube by p series. P is greater than 1, then it is CGT. So by the p series, 3 is always greater than 1, so it is convergent sequence. So this option is wrong because I have to find out divergent. Next problem is obviously divergent by Cauchy condensation theorem. By Cauchy condensation theorem, summation an is convergent implies 2 to the power k, a to the power 2k, a into 2 to the power k, summation is convergent. Now log summation n equals to 1 to infinity log n by n equals to summation 2 to the power k into 1 by 2 to the power k equals to log 2 to the power k, which is divergent dgt. So in this portion is divergent, and similarly this portion is convergent, and this portion is also convergent because square sine 1 by n by comparison this is CGT, so it is CGT 1 by n tan 1 by n equals to 1 by n squared. This is also CGT. So friends, we get only one divergent. Now we will solve question number 35. Question number 35. E is equal to 2x cubed plus 3x squared minus 12x. So this is equals to x into 2 minus 12, and this is, I take it, this is at fx and k dx equals to k. So f dash x is equal to 6x squared plus 6x minus 12, and that equals to 6 into x plus 2 into x minus 1. If minus 2, so x is equal to minus 2 and 1. If minus 2 equals to, putting this value, we have 18. So let's try to draw a curve. This is axis x dash, this is axis x. So friends, our extremum point is in here is 2 and 1. We get 2 extremum this is minus 2, this is 1, 2 extremum point. As f minus 2 is 18, so the graph will go this way, and if 1 equals to minus 7, so it is negative. So extremum point is in here. This way is extremum point. So this is the extremum point, and this is, so this is maximum, and this is minimum. So k is always positive. So k will be this way, k will be this way, otherwise this way, positives. So whatever we see, k value
If we want to get three distinct real roots, that is possible, then k is less than 18. So the possible value of k is 16. Our option is in here. Here option is option 16, 20, 20 is maximum, 26 and 31. This is the IIT JAM question. So this question is correct. Problem is IIT JAM 2020. Next problem. Solution. Solution. Solution is x equals to box x plus integral part of x. So box x equals to x minus latest integer part of x, and you can write this equation: limit x tends to 0 plus x 1 by x plus up to plus by x. So this equation is limit, can be written limit x tends to 0 plus x 1 by x minus 1 by x 2 by x minus 2 by x. Ten by x minus, this is the 10 by x. So I can write this means limit x tends to 0 plus equals to x tends to 0 plus h. So limit h tends to 0, h 1 plus 2 plus 3 plus 10 divided by h minus 1 by x minus 2 by x. 10 by x. We can write it 10 by each, each, each into h into limit h tends to 0. So my possible value is 1 plus 2 plus 3 plus 10 plus 0 equals to 10 into 10 plus 1 divided by 2 plus 0 equals to 55. So my answer is 55. Now we will solve another problem. Limit n tends to infinity 1 by n summation I equals to 1 by n 5 to the power I by n summation j equals to 1 by n 1 by n 5 to the power j by n so we can write this way that integration this is equals to integration 0 to 1 x into 5 to the power x dx this portion and another is 0 to 1 5 to the power x dx equals to divided by ln 5 minus 5 to the power x divided by ln square 5. 0 to 1 and 5 to the power x ln 5 0 to 1 equals to 5 ln 5 minus 5 ln square 5 plus 1 by ln square 5 equals to 5 by ln 5 minus 1 by ln 5 equals to minus 16 ln square 5. The exponential function satisfies the following properties: ex does not equals to 0, ex plus y, ex into ey, x comma y belongs to r, r equals to e to the power r. The exponential function e is strictly increasing on r, has range is equals to y belongs to r and y greater than 0, And further, we have limit x tends to infinity minus infinity to ex equal to 0, limit x tends to infinity ex equal to 0, and e such that r tends to r such that e dash x is equal to ex and e0 is equal to 1. So friends, this is my exponential series. Next is Lipschitz function definition. Let a subset of R and let f such that a tends to R if there exists a constant k greater than 0 such that fx minus fy less than equals to k into x minus y for all x and u belongs to a, then f is said to be Lipschitz constant on a. Theorem: if f such that a tends to R is a Lipschitz function, then f is uniformly continuous on a. Next is signum function. Signum function is plus 1 when x equals to 0, 0 when x equals to 0, minus 1 when x is less than 0. Theory: let un and vn be bounded sequence and then limit per unit, and upper limit of un, upper limit of vn is equal to upper limit of un plus vn, lower limit of un plus vn is equal to lower limit un plus vn. A bounded sequence un is convergent if and only if lower bound of un is equal to upper bound of limit un. Theorem: let un be a series arbitrary terms and Pn equals to un plus mod of un and Qn equal to un minus mod of un. Then if un is absolute convergent, then both Pn and Qn are convergent. If un is conditionally convergent, then both Pn and Qn are divergent. Now we will solve 38. So friends, let's start to solve this problem. If n such that 0, 1 tends to r, be given if nx equals to 2x square divided by x square plus 1 minus 2nx whole square. So the sequence is converges uniformly on 0, 1, does not convergence uniformly 0, 1, but has subsequence. The convergence uniformly on 0, 1 does not converges pointwise on 0, 1 converges pointwise, but does not have subsequence that convergence uniformly on 0, 1. So friends, my sequence is fnx equals to 2x square divided by x square plus 1 minus 2nx whole square, and fx equals to limit n tends to infinity fnx, that is limit n tends to infinity 2x square divided by x square plus 1 minus 2nx whole square equals to 0. So fx is 0. As limit n tends to infinity fnx equals to 0, where x belongs to 0, 1 pointwise, so it is pointwise convergent. Pointwise convergence, we know that if sequence is convergent, then subsequence also converges to L. If sequence is convergence, then its subsequence is converges to L. If n x equal to 2x square divided by x square plus 1 minus 2nx whole square. So mn test limit n tends to infinity minus fx tends to 0 if it is UC. Now y, this is this value y, this is y, and so y dash equals to 2x square by x square plus 1 minus 2nx whole square. So whole square it is 4x, and it is 1 plus 1 minus 2nx whole square minus 2 into 1 minus 2nx equals to 0. So we get x is equal to 1 by 2n, and after that mn is equal to supremum. This portion is supremum, and still it is not. It is UC, then it is tends to 0, but it is not now UC. So we get limit n tends to infinity supremum. If I put this value 2x square equal to x square plus 1 minus 2nx whole square equal to 2. So which is does not equals to 0. So it is not UC. So its subsequence is not UC. So my answer converges uniformly is wrong. Does not convergence uniformly on subsequence has does not convergence uniformly, but subsequence convergence uniformly it is not possible. Does not convergence pointwise.
but this option is correct. Now friends, we will solve next problem. The interval of convergence of the power series n equals to 1 to infinity 1 by minus 3 to the power n plus 2 4x plus 12 whole to the power n square plus 1. So friends, our given sequence is summation n equals to 1 to infinity 1 by minus 3 whole to the power n plus 2 4x plus 12 whole to the power n into n square plus 1. It can be written this way into infinity 4 to the power n minus 3 to the power n plus 2 x plus 3 whole to the power n divided by n square plus 1. It can be written as well as summation n equals to 1 to infinity n x minus x0 whole to the power n. Now capital R equals infinity un divided by an divided by an plus 1 whole to the power limit n tends to infinity equals to 4 to the power n minus 3 to the power n plus 2 into minus 3 to the power n plus 3 into n square plus 1 4 to the power n plus 1 into n plus 1 whole square plus 1. So this equation can be written this way: limit n tends to infinity minus 3 by 4 n square plus 2n plus 2 divided by n square plus 1. It can be written this way. After that we can get 3 by 4. Un an is convergent if x0 x0 minus r x less than x0 plus r. So x0 is equal to 3 minus 3 by 4 less than x into 3 plus 3 by 4. After that, we can write 9 by 4 less than x 15 by 4. So my answer is interval is 9 by 4 comma 15 by 4. Now is 1 when x equals to when x equals to 9 by 4. Friends, still it is not complete because our interval is open. X equals to 9 by 4. Hence, our equation is summation 4 to the power n divided by minus 3 to the power n plus 2 into 9 by 4 minus 3 whole to the power n divided by n square plus 1, and we can write summation power n divided by minus 3 to the power n into minus 3 to the power n divided by 4 to the power n into n square plus 1, 4 to the power n, 4 to the power n cut. So we get summation 1 by 9 into n square plus 1. By comparison test, it can be written 1 by n square. 1 by n square is convergent. So this portion is convergent. So x equals to minus 3 to the power n plus 2 into n square plus 1 into 15 by 4 minus 3 equals to 1 by 9 summation 1 by minus 1 to the power n into n square plus 1. This is alternative native this is alternative series by Lipschitz
List series limit n tends to infinity 1 by n squared plus 1 equals to 0. So x is equal to 15 by 4. It is convergent as this is un as un is md. Un is md monotone decreasing and n tends to infinity equal to 0. So my answer is my interval is 15 by 9 by 4 comma 15 by 4 closed interval. Next problem is un is equal to 1 to n e to the power minus t square into dt. Then which of the following statements is true? So friends, the both of the sequence un equals n equals to 1 to infinity and the series n equals to 1 to infinity un are convergent. Both the sequence un n equals to 1 to infinity, the series n equals to 1 to infinity un are divergent. The sequence un n equals to 1 to infinity is convergent. The sequence n equals to 1 to infinity un are divergent. Limit n tends to infinity un divided by 2 by n, 2 by e. So we will check that u1 equals to 1 to 1 e to the power minus t square dt, 1 to 2 e to the power minus t square into dt. u3 is equal to 1 to 3 e to the power minus t square into dt. u4 is equal to 1 to 4 e to the power minus t square into dt. So we plot a graph my graph is this way. This is the 1 and this is this portion. This is t. Now we choose Vn equals to 1 to n e to the power minus t square into dt less than 1 to n e to the power minus t into dt. Vn is equal to, sorry, it is un, and it is, we can choose it is Vn. So un is bounded limit and un un is strictly increasing limit n tends to infinity. Un limit n tends to infinity Vn, and limit n tends to infinity un less than equals to 1 by, as limit n tends to infinity 1 to n 1 to n e to the power minus t dt equals to limit n tends to infinity minus e to the power minus t 1 to n equals to limit n tends to infinity 1 by e minus 1 by e to the power n equals to 1 by e. Now how now e to the power minus t graph is this way, e to the power minus t, and e to the power minus t square is this way. That's why e to the power minus t square greater than e to the power minus t. The graph is this way. This way. So friends, the limit n tends to infinity un equals to 2 by e. This is not possible. And see that un is convergent, but the series un the sequence un n equals to 1 to infinity is convergent, but the series un is divergent. as limit n tends to infinity un. So series un is dgt, but sequence is convergent because sequence is bounded and increasing. So every and bounded sequence is convergent sequence. I hope I can. Yeah. Next problem is 42. Let f such that r tends to r be twice continuous differentiable function with f0 equals to f1, f dash 0. Then f double dash is the 0 function, f double dash 0 is 0, f double dash x equals to 0 for some x belongs to 0, 1. F double dash never vanishes. So if such that r tends to capital R twice continuous differentiable continuous differentiable function. So f1, f0 and f dash 0, and example, for example, fx is equal to x square into x minus 1. So f1 equals to 0, f0 is equal to 0, and f dash 0 dash 0 equals to 0. So we construct, we give an example. Now functions root is 0 and 1 as f dash 0 and f dash x equals to 3x square minus 2x and f double dash x equals to 6x minus 2. So if we put 0, so if we f double dash 0, I discard it. F double dash is the 0 function. I discard it. F double dash x is equal to 0 for some x belongs to 0, 1. This is accepted, and f double dash never vanishes. This is discard. I discard this because x is equal to 1 by 3 belongs to 0, 1. Let Sn is equal to k equals to 1 to n. Which of the following is true? S by 2 to the power n greater than n by 2. Sn is bounded sequence, and s to the power n into s to the power n minus 1 tends to 0, and Sn tends to N by n, it tends to 1. So friends, according to the question, whatever we see, solution S1 equals to 1, S2 equals to 1 plus 1 by 2, S3 equals to 1 plus 1 by 2 plus 1 by 3. So S 2 to the power n then equals to n by 2. For all n greater than 1, S4 is equal to 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 equals to 25 by 12, and so S2 is greater than less than mod of S into 2 to the power n into S into 2 to the power n minus 1 1 1 equals to mod of summation k equals to 1 to 2 to the power n 1 by k minus summation k equals to 1 to 2 to the power n minus 1 1 by k. So S3 so that this portion Sn is bounded. It is wrong. It is wrong because we see there is no upper bound, and this portion is to the power 2 to the power n minus s 2 to the power n minus 1. This is as n tends to infinity. This value is, it can be written this way: first portion is 1 by 1 by, very simple way friends, simple way, take
n equals to n equals to 4. So n minus 1 equals to 3. Sorry, n equals to 1 and n minus 1 n equal 2, n minus 1 equals to which is best. Okay, n equals to 2 and n equals to n minus 1 equals to 1. So 2 to the power 2 square equal to 4 and 2 to the power 1. So I can write summation k equals to 1 to 4 1 by k minus summation k equals to 1 to 2 1 by k can be written 1 by 3 plus 1 by 4. So friends, similarly in case of for generalizations, general case, we get 1 by 2 to the power n minus 1 plus 1 by 2 to the power n plus 1 2 to the power n plus 2 up to 1 by 2 to the power n minus 1 we get, or it is 2 to the power n plus 1 2 to the power n minus 1 2 to the power n minus 1. This way we can write. So n tends to infinity. As n tends to infinity, so what we can get, we can take common 1 by to the power n. It tends to 0 according to me. I hope this portion is correct. And Sn by n divided it tends to 1. Actually, this kind of function is harmonic function Hn. So Hn by n tends to 1, as n tends to infinity is not possible because it tends to 0. So this portion is wrong. Next, let f such that 0 comma infinity and 0 comma infinity be continuous function. Which of the following is correct? So which of the following is correct? There is x0, x0, belongs to 0 comma infinity such that fx0 is equal to x0 if fx less than equals to m for all x belongs to 0 comma infinity for some m greater than there exist 0 comma to infinity such that fx0 is equal to 0. If f has fixed point then it must be unique and f does not have a fixed point unless it is differentiable on 0 comma infinity. So let's draw a graph. This is y equals to x, y equals to x if such that 0 comma infinity to 0 comma infinity. So if x there exists x0 comma 0 comma infinity such that fx0 is equal to x0. So fx equal to x is a continuous function and this is y-axis and this is x-axis. So there is x0 belongs to 0 comma infinity such that fx0 is equal to x0. So this option is not correct. If fx greater than equals to m for all x belongs to 0 comma infinity or some m greater than 0, then there exists such that fx0 is equal to x0. This is correct because it is continuous property. If f has fixed point, then it must be unique. It is not correct. F does not have a fixed point unless it is differentiable on 0 comma infinity. This option is not correct. So only one option is correct. Number 45. Limit n tends to infinity 1 by root over n divided 1 by root 2 plus root 4 plus 1 by root 6 plus root 4 plus up to 1 by root over 2n plus 2 plus root over 2n. So my n can be written 1 by root over 2n plus 2 plus root over 2n root over 2n minus 2n plus 2 divided by minus 2 1 by 2 into root over 2n plus 2 minus root over 2n. Now limit n tends to infinity 1 by root over n 1 by 2 minus root 2 minus root 4 minus 1 by 2 root 4 minus root 6 up to minus 1 by 2 root over 2n minus root over 2n plus 2. So we have that limit n tends to infinity 1 by root over n into root over n plus 2 minus root over 2n. After that we get 1 by root 2 plus limit n tends to infinity, minus into root 2, so it is root 2 by n root n equals to 0 plus 1 by root over 2. So my answer is 1 by root. So this is my answer. So next problem is the equation of 11 to the power x and 13 to the power x, 17 to the power x minus 19 to the power x has no real root. No real root, exactly 2 real roots, only 1 real roots, and more than 2 real roots. So how to solve this problem? So we can write this way: 11 to the power x plus 13 to the power x plus 17 to the power x is equal to 19 to the power x. So fx is equal to by 19 whole to the power x plus 13 by 19 whole to the power x plus 17 by 19 whole to the power x. So limit n tends to infinity. Limit x tends to infinity fx is equal to minus 1 equals to 0 equals to minus 1, and f dash x equals to 11 by 19 whole to the power x log 11 by 14 plus 13 by 19 whole to the power x log 13 by 19 17 by 19 whole to the power x log 17 by 19. This value is less than 0, so it is strictly decreasing function. So as it is strictly decreasing function, so only one root, only no real roots, this is wrong. Exactly 2 real roots, this is wrong. Only one real root, this is correct. More than 2 real roots, this is wrong. Now we discuss some theory. If such that A tends to B, mod of A equals to M, mod of B equals to N, total number of function is equal to codomain to the power domain n to the power M, total number of one function is equal to npm codomain p domain, total on number of onto function is equal to r equals to 1 to n minus 1 to the power n minus r ncr r to the power m. So this is the value. Number 47, Let ai equals to bi equals to 0 for each n greater than equals to 2, n and bn be real number given by an equals to m equals to this and bn equals to m equals to log m whole square. So both n and bn are divergent, both n and convergent, and bn is divergent, n is divergent, and bn is convergent. This type of problem we have to solve. We will solve at first this problem we will solve. After that we will solve that problem number 50. I leave. So for x comma y belongs to R square, consider the series limit n tends to infinity lk equals to 0 to infinity and k square x to the power k y to the power l. Then the series converges for x comma y in 1. So what I have to solve, limit n tends to infinity. I can write this way, equals to 0 to n y to the power l divided by l factorial, and limit n tends to infinity equals to k equals to 0 to n a square x to the power k. So we can write this way. Number 1 by r1 equals to limit n tends to infinity mod of an plus 1 divided by an. So it can be written limit n tends to infinity n factorial divided by n plus 1 into n factorial, that is cut. After that we get it 0. We take it n equal to 1 by n factorial by r2. I can write limit k tends to infinity k plus 1 whole square divided by k square equals to 1. R2 equals to 1. So radius of curvature equals to R1 equals to infinity. Problem is R cross 1 comma minus 1. This option is correct. So I can tell this option is correct. 1 comma minus 1, this is correct. R cross minus 1, R cross R, this is not correct. R cross number 3 minus 1 comma 1 is correct. And after that this portion is not correct because R cross minus 1 comma 1, R is belongs to x, R is for y, and this is for x. So x comma y belongs to a cross b, x belongs to a and y belongs to b. So according to the rule, x is and y this. Now whatever we see that x is minus 1 comma 1 and y is infinity. So this portion we can say it is not. This is x and this is y, so that's why option 2 is wrong. So friends, now we will go to solve this problem. How can I solve? Friends, now we number 48. How to solve? A n equal to minus 1 to the power n 1 by 2 minus 1 by n. Let Bn is equal to k equals to 1 to infinity ak, and let and which is option is true. Limit n tends to infinity, Bn equals to 0, supremum Bn equals to half, limit infinity, Bn equals to minus half. So friends, whatever you see that B1 equals to A1 equals to 1 minus half, B2 equals to A2 equals to half 1 minus half plus half minus half minus half. Similarly, B3 is equal to A3 equals to 1 minus half plus half minus half plus 1 by 3 minus half. So Bn equals to, you can write 1 minus half plus 1 by 3 minus 1 by 4 plus up to plus 1 by n, where n equals to even, and 1 minus half plus 1 by 3 minus 1 by 4 plus 1 by n minus half. So this case is n equals to, now apply log 1 plus x is equal to x minus x squared by 2 plus x cubed by 3 minus x to the power 4 by 4 up to infinity. So Bn equals to log 2 minus half when n tends to infinity and n is odd, and Bn equals to log 2 when n tends to infinity, n equals to even. So friends, whatever we see that this value is 0.693 and this value is 0.193. Now the question is that limit n tends to infinity, supremum Bn equals to 2 Number 2, this is correct. And infimum bn minus half, this portion is wrong. I hope I can clear this question. Now we will solve the next problem. This problem we will try to solve. So an is equal to summation m equals to 2 to n minus 1 to the power m into m divided by log m whole to the power m, and bn equals to summation m equals to 2 to n divided by 1 by log m whole square. So am whole to the power, this is am, this is bm. So am whole to the power 1 by m equals to m to the power 1 by m log m whole to the power m by m is equal to 0, so less than 1. So it is CGT, convergent sequence. So both an and bm are DGT. This is wrong. And an is DGT and bn is convergent. This is wrong. Option 2 is correct because bn is divergent. So let's start. This in 0 and bm whole to the power 1 by m limit 1 by log, so it is CGT because less than 1 by the Cauchy's formula. So this option is also wrong. So an and bn both are CGT, convergent. Now we have only last problem. The problem is this: sine squared x plus 1 by n. If n(x), this problem is last problem, friends. For n greater than equals to 1, let gnx is equal to sine squared x plus 1 by n. If n(x) is to 0 to x gnx gnt dt. So then fn converges pointwise to a function f1 0 to infinity. Fn does not converges pointwise. So I have to check it is uniformly convergent or not. So how can I solve this? My gnx is equal to sine square x plus 1 by n and fnx equal to 0 to x gn t dt limit n tends to infinity gn is equal to sine squared x. Now limit n tends to infinity fnx equal to limit n tends to infinity 0 to x is equal to fx minimum of gn minus g x belongs to I. So supremum of minus sine square x equals of into supremum x belongs to I cos 2x minus cos 2 into x plus 1 by n. Now this portion y is equal to, we can say, sine square x plus 1 y dash is equal to sine x plus 1 by n cos x plus 1 by n minus 2 sine x cos. It can be written this way. We can say that equals to 0. So sine 2x plus 1 by n is equal to sine 2x. So 2 into x plus 1 by n minus 2x plus pi, I can write. So 4x pi minus 2 by n, and after that x equals to 2x is equal to pi by 2 minus 1 by n. Therefore, supremum of this equal to the value in here. So 1 by 2 supremum x belongs to I sine pi by 2 minus 1 by n minus cos pi by 2 minus 1 by n plus pi by minus 1 by n divided by 2 by n. The result is sine 1 by n. Now next is 0 to x sine t dt, sine square t dt. So it can be written half into 0 to x 2 into sine square t dt. It can be written as half into 0 to x 1 minus cos 2t dt, and after that half to t minus sine t plus 1 by n into 2 0 to x half of x minus sine x plus 1 by n divided by 2. Supremum of fnx minus fx equals to 1 by 4 minus sine 1 by n. Sine 3 as tends to infinity, so this is tends to 0. So our assumption fnx converges pointwise to a function 0, e and does not and not UC. This option is wrong. So if x converges, this option is this is does not converges. This is wrong. This portion fnx is converges on 0, infinity. This option